Hello everyone, welcome to my fourth Arduino tutorial. So today we will discuss about the digital input. Here is my digital input, which is micro switch. Now let's understand the wiring of this micro switch. Okay, now first of all drag your micro switch on your breadboard, and if you see this very interesting property in micro switch, these two terminals are shorted with each other. Okay, now let's do the wiring. First of all, we will add 5 voltage to one terminal of your micro switch. That's perfect. Okay, and now let's add some resistor. That I will show you in the programming why we are adding resistor. Okay, now let's change the color to black. Oops, sorry. There's my ground. Now let's connect the ground from the Arduino board. Now let's zoom it. Yeah, perfect. It's perfect. Now drag your output. Can connect it to pin number 5 of my Arduino board and change the color of white to blue. So that's all about my wiring section. Okay, now let's understand the programming part. So here's my wiring software. Now let me remove my resistor from micro switch. Now I have connected micro switch to pin number 5 of Arduino board. Now I have a white setup section. As you know, micro switch is an input component. Pin mode button is taken as an input. Now let's begin the serial communication. 9600. Okay. Now white, blue. So first of all, we will read the digital input, which is micro switch. So the keyword we use, digital read button. Now let's store the value of this button to a variable. You can take any variable. Okay, now let's print this value. Serial.print ln al. Let's put some delay so that we could read the value. Now upload the code on your Arduino board. Now open the serial monitor. You see, I haven't yet pressed the button and values are 1100. If I press the button, values are still 000. 100 1111. So it is basically an electrical noise, okay, coming from the Arduino board. To remove this noise, we add 10 kilo ohm resistor to ground, which is my pull down resistor. Here's my ground terminal. Here's my ground. Now you see the values are 00. If I press the button, value is 1. If I release the button, value is 0. If I press the button, value is 1, then 0. 1 0. Okay. That's perfect. Now let's do our next exercise. Now in our next exercise, we want to turn LED from our micro switch. If I press the micro switch, and LED should turn on. If I press it, LED should turn off. Okay, so let me add LED. Okay, sorry, change the color to black. Now connect your LED to pin number 9. You can connect to any pin. Change the color to blue. So that's it. Now let's do our programming section. Okay. Now let's start our coding part. Now I have connected my push button to pin number 5 and LED to pin number 9. So in pin equals to 5, in LED equals to 9. Now I am declaring two variables which track the state of my push button, which is initial state and final state. Initial state and final state. And I am also declaring a variable which counts the number of state, which means how many times the button has been pressed, which initialized 0. So go and set up pin mode. In pin is just input. Pin mode. Sorry. LED is your output. Okay, now let's do our while loop section. First of all, we'll read the digital pin, which is my final state, equals to digital read in pin. Okay, now if two states are not equal between final state or initial state, and which means my button has been pressed. So I'll write final state, sorry, is not equals to initial state. Okay, which means my button has been pressed. So if final state equals to high, okay, now I'll start my counting. Okay, now here I will write initial state equals to final state. This is to store the next variable. Okay, otherwise new variable. Now I'll feed my count to switch, and now I'll show why I have written this. Okay, now I have same code. Okay, now this is the modulus operator in C language. Okay, it is basically divide two variables, but this modulus operator returns remainder instead of quotient. Okay, now here I need two conditions. If I press this button, my LED should turn on. If I again press this button, my LED should turn off. So that's why I wrote the simple code and store the result into new variable C. Now let's check it out how it works. Now I'm uploading my code to Arduino board. Okay, and here I open the serial monitor. Now if I press my button, value is 1. If I again press this button, value is 0. If I again press this button, value is 1, 0, 1, 0, 1, 0, which means it satisfied my conditions, required condition. Okay, now here I'll make two cases. Case 0, in which I'll turn off my LED, digital write LED low, break, case 1, digital write, LED high. Okay, break. Now I'll upload my code. Oh, sorry. I wrote. Sorry, the spelling mistake. Okay. Now I'll press my button. LED got turned on. If I again press my button, LED got turned off. Here you see the problem. Okay. Actually, it is due to the hardware structure of my push button. This is my ideal state in which button should go if 0 to 1. Suppose if I press my button, then it should go low to high, that is 0 to 1. But in this case, if I press this button, the button goes up and down for few milliseconds, which is called bouncing. Okay, so to remove this bouncing, we'll add some editing in our code. Okay, now for that I'm going to put some delay, because here I know my button has been pressed. Okay, now to remove the bouncing, this is my bouncing, which is for few milliseconds. Okay, it means I have to read the button after few milliseconds. That is 10 milliseconds is enough to remove the bouncing. Okay, it's perfect. After 10 milliseconds, I'll read my push button, which is the actual status. This one. Okay. Now I'm going to upload my code. Come on. Okay, that's it. Oh, that's perfect. So that's all about debouncing of a switch. So thank you for watching my video.